Hello, this is EDEXCEL A-Level Maths 2021 Pure Paper 2. First question, arithmetic series. Well, the formula for the nth term, which you're not given, is that an is equal to the first term plus the number of terms minus 1 times by the difference. So we can apply that to, both of these bits of information at once, really. Because let's look at the 21st term. So a in the 21st position is equal to the first term a, which we know is 16, plus n, the number of terms 21 minus 1 multiplied by the difference. And we know that the a21 is 24. So 24 equals 16 plus 20d. So therefore subtracting 16 will give you 8 is equal to 20d. So therefore d is equal to 8 over 20, which is the same as 2 over 5. The summation formula is given. That's Sn is equal to n over 2, open brackets, 2a plus n minus 1 multiplied by d. And we just have to apply this, and it's asking for the first 500 terms of the series. So 500 over 2, open brackets, 2 times the first term is 16, so 2 times 16, plus 500 minus 1 multiplied by 2 over 5, which was the d value which we found from the last time. So on my calculator I would do 500 over 2, open brackets, 2 times 16, plus 499 times by 2 over 5. And we get a value of 57900. Okay, question 2 is a functions question. Now, the range of a function is always quite difficult to work out. Most students struggle with this because each function is different, and the best way to ascertain what the range is really is to draw a quick sketch. If you've got a graphical calculator, then that makes it a lot easier, but this one should be fairly straightforward because we've got 7 is the intercept. It's going to be a negative x squared, so we're going to get this type of shape. And I think it's quite obvious to see from here that the graph will never go above 7. So therefore the y value will never go above 7. So the range is always trying to work out what values the y can take. And because it can't go over 7, we can say the range of f, so f of x, is less than or equal to 7. Because it can equal 7, that happens when x equals 0. This one is a composite function. It asks us to work out g f of 1.8. So I'm going to put 1.8 into f, and then I'm going to put that answer into g, like that. So the first thing I need to work out is f of 1.8. So I go to my calculator, and I type in 7 minus 2 times by 1.8 squared, and that's going to give me 13 over 25. And the next thing I need to do is work out g of that new value, 13 over 25. So again, I'm going to go to my calculator and I'm going to do 3, let's open up a fraction first, 3 of 13 over 25. And let's put that, let's do 5 lots of 13 over 25, and then minus 1. Press equal, we get 39 over 40. And the inverse function is next. Well, the way that I work out the inverse function is I write y equals 3x over 5x minus 1. And then what I want to do is I want to swap the x's and the y's. So that y will become an x, and these x's will become y's, which is essentially reflecting the function in the line y equals x, which is what a inverse does. Then I need to make y the subject. So I'm going to multiply both sides by that denominator to get x 5y minus 1 is equal to 3y. Multiply out the brackets, 5xy minus x equals 3y. I will then collect all the y's on the same side. So I get 5xy. I'm going to move that to this side, become minus 3y, and I'm going to move that one to that side, become positive x. I'm going to take out a factor of y. Oops, that should be a 3. And then finally I'm going to divide through by that factor to get that y equals x over 5x minus 3, and that is the inverse function of g. So inverse g of x is equal to x 5x minus 3. And I think that question is done. This question we need to use log rules. So we need to know that the logarithm of x minus the logarithm of the same base of y is equal to the logarithm of that base of x over y. And the same is true if you're, or similar is true if you are adding two logarithms. You guessed it, we're going to multiply them together. So in this case we are subtracting them, so we will have the log of, in base 3, 12y plus 5 over 1 minus 3y, and that's equal to 2. Now what exactly is a logarithm? Well, a logarithm of, in base 3, of something, let's call it x, and let's say that's equal to 2. This basically means that you've taken the number 3 as a base, and then this is the power here, and that's equal to what we're taking the log of. So in this case, we're going to have 3 squared is equal to 12y plus 5, 1 minus 3y. And of course, 3 squared is 9. So then solving this, I'm going to multiply that bracket up there to get 9 minus 27y is equal to 12y plus 5. I'm then going to add 27y to both sides to get 39y. I'm going to subtract 5 to get 4. So I'm going to get y is equal to 4 over 39. Right, question 4, small angle approximation. You need to know your small angle approximation. So for small angles, sine theta is roughly theta, tan theta is roughly theta, and cosine theta is roughly 1 minus theta squared over 2. You must know those. Now, this one we're asked to do 4 sine of half theta plus 3 cos squared theta. Cos is the most tricky one, so I'm actually going to rewrite this and just remove the cosine, because we know that, of course, cos squared plus sine squared equals 1, so therefore cos squared is equal to 1 minus sine squared. So let's just write that instead. So I have 3 lots of 1 minus sine squared. It's just going to make this question much easier. Let's look at this one. If sine of theta is approximately theta, well then sine of theta over 2 is approximately theta over 2. I'm going to times that by 4. Plus 3 lots of 1 minus, well, sine, again, is just theta, so sine squared is theta squared. Multiplying this out, that's going to give me 2 theta. That's going to give me 3, and this is going to give me minus 3 theta squared. And there we have it. You might want to write it in the way that asks you to find it, but there you go. Working out the derivative. Well, we should know that the derivative of a polynomial, we bring the power down, so 4 multiplied by 5 is 20, and then we drop that power down by 1. So 3 times minus 24 is minus 72, drop down by 1, 84, drop down by 1, 1 times minus 32 is minus 32, drop the power down to 1 gives you 0, which is just 1 itself, and any constant differentiates to 0. The second derivative, well, I just differentiate this next one, the first derivative. So I'm going to get 60x squared, 144x, and 84. I sometimes see students inexplicably decide to like factorize these, or maybe even divide them. That is the gradient function. Well, this is the gradient function, and this is the change of the gradient. They are values, so we can't just divide them, even though they have a factor. Right, next we're asked to verify that there's a stationary point. Well, we know that stationary points happen when dy by dx equals 0. So let's check what dy by dx equals when x equals 1. Well, I will get 21 cubed minus 72 1 squared plus 84 times 1 minus 32. Because it's asking me to verify, I'm going to evaluate each term so it's clear to the examiner what I'm doing. Because essentially it's a show that question. And I think now it's safe enough to say that that equals 0. Yeah, because you've got 104 and minus 104. So you say equals 0. And then conclusion, you're going to say that as dy by dx equals 0, there is a stationary point at x equals 1. So important to put that conclusion statement in for any show that or verify question. Okay, next, show that this stationary point is a point of inflection. Well, a point of inflection occurs when the second derivative is equal to 0 and there is a change of sign in the second derivative around the point. So what do I need to do? Well, I need to set up a little table where I write x and I write the second derivative, and I have the point 1, which is the point we're investigating, and I need to go a little bit below and a little bit over, and we're looking hopefully for a change of sign. Don't go too far below or too far over, because if there is another stationary point in and around the point there, you're likely to make a mistake. So just go like 0.1. So first off, we will get the second derivative when I sub in x is 1. That is going to give me 0 as suspected. And now what I need to do is I need to sub in 0.9 into the second derivative. So let's do that. Let's go for 60, 0.9 squared minus 144 open brackets 0.9 plus 84, and we get the number 3. And then let's do the same, but change these to 1.1s. And hopefully we get a different sign. Great, negative 1.8. Negative 1.8. That's fantastic. So what does that actually show? Just quickly. It shows that at x equals 1, there was some sort of turning point there, let's say. And then we've got a positive second derivative, which means there is a type of minimum shape. So let's imagine the curve's coming down like this. And then on the other side, we've got a negative value, which means there's some sort of maximum shape. So you get that point of inflection there, where it's neither a maximum or minimum. Essentially, I've already done the conclusion by writing this here. Perfect. But always write a conclusion statement. Okay, so for these types of questions, there's two formulas that you need to know, and that is, whoops, that's highlighter, arc length, so arc is equal to r theta, and also area of sector, which is equal to a half r squared theta. And what we're looking for here, we're looking for the size of AOB. So I go from A to O and then up to B, and that's the angle I'm looking for. Let's call it alpha. And we can see that by symmetry, this also must be alpha. So we can see that 2 alphas plus theta will equal 180 degrees. But in radians, that is pi, because pi is 180. So by looking for the angle we want alpha, we need to subtract theta and then divide by 2. So that is the answer for part A. Part B, it says show the area of the logo. Okay, well then let's first off look at this area. Let's call it area 1. So that is a sector, and we know the area of a sector is equal to a half r squared, which is r, multiplied by the angle, which we worked out was alpha, which we worked out was pi minus theta over 2. And then let's look at this one, number 2. And that one is again the same formula, but this time the radius is 2r, so you have to put that in brackets and then square it, which is important, and then multiply by the angle, which is in this case theta. So the total area is going to be 2 lots of 1 plus a 2. So 2 lots of 1, well, that half needs to be multiplied by 2 to get just 1, so it's r squared pi minus theta over 2, plus the larger sector, which is 1/2 times 2 squared is 4, times a half is 2, so 2r squared theta. And okay, that's not quite what I've got right now, which is a bit alarming. Don't panic, let's see if we can work this out. So that 2 there is essentially a half, so that could come out to the front, and then we've got r squared times by pi, and then we've got minus r squared times theta, and then we've got plus 2r squared theta. Okay, we can take out a half r squared, which will leave me with pi minus a theta, and if I take out a half from 2, I'm left with 4 left over, so 4 theta. So that does give me the half r squared pi plus 3 theta, or let's write it the way they want it, so 3 theta plus pi. And it says find the perimeter of the logo. Okay, so the perimeter of the logo, let's look at this bit by bit, is r another r. This distance here is 2r, but then the bit that we want, which is just that, is going to be just 1r, because I need to take away this bit here, which is also r. So that's another r. And then there's another one here, so that's another r. And then I need to find two of these blue arcs, which are, we need two of those, and they are, using the arc length, they are r multiplied by that angle, which we know was pi minus theta over 2. And what else do we need? We need the larger arc length as well, and that is going to be just 2r is the radius, so plus 2r, and the angle is just theta. Okay, so let's add these all up down here. We've got 4r, we've got that 2 and that half will cancel, so we've got r pi and minus r theta, and we've got plus 2r theta. So in total we've got 4r plus r pi minus, plus 1 r theta. Lovely. Question 7, you've got a lovely graph there, and a cubic, and it says the point P, you get given it, and the line is tangent at P. Use differentiation to find the equation of the line L. Okay, so that shouldn't be too tricky. So let's first differentiate the function. So dy by dx is equal to 3x squared minus 20x plus 27. Let's then work out what dy by dx is at the point x equals 5. Well, that's equal to 5 squared minus 25 plus 27. So we can use our calculator to do that. 3 times by 5 squared minus 20 times by 5 plus 27. And we get a gradient of 2. Lovely. And now we can use our formula y minus y1 equals mx minus x1, which I recommend everyone uses, not y equals mx plus c. Ugh. Let's use this one, much neater and quicker. Y minus 13 is y plus 13 is equal to m, the gradient 2, x minus 5. So expanding that bracket is going to give us 2x minus 10. So therefore y is equal to 2x minus 23. Perfect. It says, hence verify that L meets C again on the y-axis. Okay. 1 mark. Well, it's quite obvious because they both have the same intercept, but I'm not sure how to verify that. Well, I guess we could say at x equals 0, curve C, y equals minus 23, and line L, y equals minus 23. So they both pass through 0 minus 23. bit of a weird question, that one, because it's just like really obvious, but whatevs. Okay, now we need to use algebraic integration to find the exact area bounded between the line and the curve. Well, let's look at the diagram. I know that 0 is the kind of start point of where that area starts, and 5 is the end point of that area. Now, in order to work out the area between a line and a curve, or vice versa, you would take the one on top, which is the purple curve, and then you would subtract the line, or whatever the line or curve which is below the region. So that's what I'm going to do. So I'm going to integrate between 5 and 0, because those are our 2 bounds, the curve on top, which is that polynomial, minus the line which is on the bottom, which is 2x minus 23. Okay, so let's grab some space here. So that's the same as me integrating between 5 and 0. X cubed minus 12x, no, sorry, minus 10x squared plus 25x, and then those minus 23s will cancel, and dx, whoops, get told off for not writing dx. Okay, great. Well, let's integrate that. So up the power to 4, divide by the new power, up the power to 3, and divide by the new power, up the power to 2, and divide by the new power, and then I need to sub in 5 and 0. Well, let's sub in 5, because 0 is just going to give you 0, because they're all x terms there. So 5 to the 4, divided by 4. Haven't done that very well. Okay, let's just write out each term, so that then at least our examiner knows that we know that we're doing what's right. We've got 10 times 5 cubed is 125, and then that's divided by 3. So that's minus 1250 over 3. And then we've got 25 times 5 squared, which is also 25, and then that needs to be divided by 2. So plus 625 over 2. Right, let's add those all up then. So let's add on a 625 over 4. And then let's take away a 1250. I haven't done this, not the smoothest way of doing this, but we end up with the right answer, which is 625 over 12. Perfect. Yep, that's all good. Always, top tip, always just go back once you've done a question and just read the question again to make sure that you've answered every aspect of it. Question 8, beast question incoming, so prepare yourself. I tend to like some of the hardest questions tend to be around 8 or 9, just when you're sort of getting into the paper and then they start throwing some nasty stuff at you. First off, this is implicit differentiation. Now, if you don't know, implicit differentiation is when you are trying to differentiate with respect to x something which is in fact in terms of y. Well, what you do is you just differentiate it, imagine like you're differentiating with respect to y. And then you multiply by dy by dx, because that way we end up with the same thing, dx of 3y. So we just differentiate with respect to y and then times it by dy by dx. Okay, let's go. Differentiating this, the 3 comes down, so we get x, 3 comes down times by p, gives me 3p x squared. The next one is a product. So what I'm going to do is I'm going to write here u equals qx, and I'm going to write v equals y. When I differentiate this one, I get just q, and when I differentiate this, again, if I differentiate with respect to y, I get 1, but I've got to times it by dy by dx, so I get dy by dx. So the product rule tells me I've got to times across like this to get qx dy by dx, and then I need to times across like this, and I get qy plus qy. And then I've still got to differentiate this 3y squared, which if I do it with respect to y, I get 6y, but then I've got to times it by dy by dx. And if I differentiate 26, it's a constant, so it goes to 0. Okay, now what I need to do is I need to collect those dy by dx terms on one side. So I've got qx dy by dx, and I've got 6y dy by dx, and everything else can go over to the other side. So that gives me minus 3px squared, and it gives me minus qy. Now I can factorize out dy by dx, and that gives me qx plus 6y, and that's still equal to 3px squared minus qy. And then I can divide through to make dy by dx the subject, and that gives me 3px squared minus qy all over qx plus 6y. Now, let's have a look at these integers then, so to make sure that this is right. So a is minus 3, that would be good. B would be minus 1. C would be just 1. Oh no, C would be 6, sorry. Yes, that works, great. Now he says, given that the point blah 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 lies on C and the normal to C at P has that equation, find the value. So we are trying to find two values, P and Q, and they have given us 2 bits of information. So I'm suspecting we're going to need to use both of these bits of information and solve simultaneously. So let's start with the green. It tells me that that point lies on C, which means that it must satisfy the original equation for the curve. So I'm going to sub that point in to the curve. Okay, so let's do that then. I'm just going to do it up here so I can see. X is minus 1. Qubit gives me minus 1, times it by P. We've got Q multiplied by X times Y, so that's 4 times by Q, so that's 4Q. And then we've got 3Y squared, so Y is minus 4, square it 16, times 3, 48. And that equals 26. So I can say my green equation is minus P plus 4Q, and then that's equal to minus 22. And that comes from my green bit of information. Okay, now I need to use the yellow bit of information. And we are told that the normal to C has that equation. So let's first off find what the gradient is at P. Well, dy by dx when at P is equal to, well, let's sub in P into the gradient function. So I've got minus 3 times P times x squared, which is just 1. So just minus 3p is the first part. We've got minus qy, so minus times by minus 4 is plus 4, so that's plus 4q there. And then all over x is minus 1, so that's minus q, and then 6 times minus 4 is just minus 24. And I'm told that that is the gradient. Okay, so that's the gradient. So, and let's look at this yellow bit of equation and try and work out what the gradient is. So that's the normal. So if I make y the subject, I'm going to get minus 19x and minus 123. And then if I divide through by 26, I'm going to get minus 19 over 26x, and I'm going to get minus 123 over 26. But importantly, this is the gradient of the normal, which means the gradient at P should be the negative reciprocal of that, which is going to be 26 over 19. Because the gradient at P is the gradient of the tangent at P, and I've just figured out that the normal gradient at P is minus 19 over 26. Okay, so here we go. That is my equation I've got from the yellow bit of information. And now we need to solve these two simultaneously. So let's rearrange that yellow one slightly. I say slightly. I'm going to times the 19 up here, and I'm going to times this denominator up to there. So that's going to give me 19 lots of minus 3p plus 4q, and that's equal to 26 lots of minus q minus 24. Expanding the brackets, triple 19 is 57, as we know from our darts. 19 times 4 is 76, and you're going to get minus 26q, and 26 times 24, I don't know, I think it might be, I'm not going to embarrass myself, 624, minus 624. Now let's bring everything to one side, so add 26q is going to give me 102q, and that's equal to minus 64. Right, so now they're in like simultaneous equation form. I'm going to go to my calculator to solve the simultaneous equations. So I'm going to go to menu, equation, simultaneous, two unknowns. I've got minus 1 for P, I've got 4 for Q, and I've got minus 22, and I've got minus 57, 102, and minus 624. I'm just praying these are going to be respectable numbers. Yes! Okay, so P equals 2, and because P was the X one, and and Q equals minus 5. Beast question. Love that. Question 9 looks horrendous. EDEXCEL are definitely trying to mess with your brain, because the last question was awful and then they throw this at you. But it's not actually that bad, it's just the notation that makes it look awful. So this means that we're summing up to infinity the terms that starting from n equals 2. So let's just sub in n equals 2 and see what happens, and see if we notice any patterns. So when I sub in n equals 2, I'm going to get 3 over 4 squared, and that's going to be times by cos of 180 times 2, which is 360. Then when I sub in n equals 3, I'm going to get 3 over 4 cubed times cos of 540. And then when I sub in n equals 4, I'm going to get 3 over 4 to the power 4 times by cos of 720. Now obviously we're not going to keep doing this forever and ever and ever, because that would be just ridiculous. But what we could do is we can look at the cosine graph and see how my values are going to change. So that's 360, gives you 1. So this is actually equal to just 1. The next, that's 540, and that's minus 1. So this one over here is minus 1. And then if we go up to 720, we're going to be back at 1 again. So it's going to fluctuate like this. So essentially what we're doing is we are, to get to the next one, we're just timesing by minus 1. And here we're just timesing by minus 1. And now let's look at the 3 quarters. Well, to get from this one to this one, I'm just timesing by an additional 3 quarters. Because the power is going up by 1, which means I'm timesing it by 3 quarters again. And again, I'm just going to be timesing it by 3 quarters. So this is actually a geometric sequence. It's a geometric sequence where the ratio is me timesing by 3 quarters and timesing by minus 1. So I'm timesing by minus 3 over 4. And what the geometric sum to infinity, which you're given in your formula booklet, is equal to is a over 1 minus r. And a is the first term, which we can calculate up here. When I square 3 quarters, I get 9 over 16. And then when I times that by 1, I stick with 9 over 16, obviously. So it's 9 over 16 over 1 minus, and the common ratio is minus 3 over 4. And this will equal, what it's going to equal, what it tells you to, 9 over 16, and that's going to be 7 over 4. Divide through by 4. So that is 9 over 28. Log graph question. If we look here at this model, we then need to express it written in this form. So what we can do is we can take log of base 10 of both sides, like so. We can then use our log rules to split up the fact that a is multiplied by L to the b. So we can then write that as a plus log 10 L to the b. And the other log rule we need to know is that if we have an exponent, in this case b, we can express that by moving it down to become the coefficient. So essentially the b comes down to the front to get b log base 10 L. And then that can be written the way round which they have, which is b log base 10 L plus log base 10 A. And that's the best way to write it because we can now line up, that variable is on the y-axis, so that could be y. This variable is on the x-axis, so that could be x. And because we have a straight line, this is y equals mx plus c, which means this term here is the gradient, and this term here is the y-intercept. Okay, so getting a bit ahead of myself there, but as you can see, just rub that out. That was when I did this question earlier. As you can see, we need to work out the gradient because that would give us the value of b. And I've been asked to work out a complete equation for the model. So therefore, I need to work out a and I need to work out b. So the gradient will be 0.45 minus 0 over 0.21 minus 0.7. So I put that into my calculator and I get 0.45 minus 0 over 0.21 minus 0.7, and I get 49 over 91. And that is my value for b. Now, I don't have a y-intercept, which would have been helpful, but I do have the equation of the line here, so I'm just going to use that to work out log a, because I know that the equation of the line is satisfied by one of these points. So let's use this one because there's a 0 in it, making it easier. So the log t value, or the y value, is 0. And then we've got b log L, and that's b, which is this 45 over 91. And log L is that variable, which is the x value, essentially, which is minus 0.7. And that is, we need to add on log A, which is what we need to find. Okay, so 45 over 91 times negative 0.7 will give us minus 9 over 26. So minus 9 over 26 is equal to, plus log A, which means that log A is equal to 9 over 26, which means that A is equal to, because it's base 10, it's 10 to the power of 9 over 26. And what does that equal? 10 to the power of 9 over 26 is 2.218. Now, does it give you three significant figures? So 2.22. 2.22, lovely. It does say find a complete equation, so it's not just enough saying A and B, which we have already written down. I have to write t equals A, which is 2.22, L to the power of B, which needs to be expressed by three significant figures, so I must actually work out the decimal, which is 495. So 0.495. And finally it says, with reference to the model, interpret the value of constant A. Well, I haven't actually read what on earth these people are doing, to be honest. T is the time of seconds that the pendulum takes to complete one swing, and L is the length of the pendulum. L is the length of the pendulum. Okay. So it is the time taken for the length. It's the time taken for one swing of the pendulum of length 1. Because essentially, if I were to sub in L equals 1, then I would get T is equal to 2.22, 1 to the power of 0.45, which is just equal to 2.22, which is equal to our value for A. So A tells us what the time is if the length is 1 meter. 1 meter. Question 11 is about modulus graphs, and it's quite a challenging one. It gives you this sketch here of that equation, and it then asks you to sketch another equation. The first thing I'm going to do is I'm going to label this graph by setting x equal to 0 and that will give me that y is equal to the modulus of minus 3k, which is just equal to 3k, which means the y-intercept of this graph is 3k. And then I'm going to set y equal to 0, and that tells me that 0 is equal to the modulus of 2x minus 3k. In order to solve that equation, I'm going to need 2x to equal 3k, so therefore x is equal to 3k over 2, or 1.5k might be easier. So that's 1.5k, that goes in there. That's the x coordinate where it hits the x-axis. So that's going to be helpful when I start sketching my graph of this function. And that function is very similar to the original one. The first thing I notice is forget about this first k in front, but if I just look at that highlight part, that is essentially the first function turned negative. And we know from our graph transformations that minus f of x is a reflection in the x-axis. So what I'm going to do is I'm going to start off by, let me just draw a bit like this. I'm going to start off by reflecting that graph in the x-axis. So that's going to look something like this, and this would be minus 3k there, and this would still be 1.5k. Now that would be perfect if the question asks us to do f of x and it was just minus that modulus, but there's also a plus k we need to consider. Now if I add on a constant, if I have f of x and I add on a constant, let's say k, then we know from our graph transformations that is a translation upwards by however much you add on, so in this case k. So I need to lift that graph up by k. So it's going to look like this, and then it's going to get up here, and then it's going to come back down like that. And it's going to cross now at minus 2k, because we've added on k. And that minimum point, the x value will be the same, but then the y value would have gone up from 0 to k. So I can get rid of this purple stuff now, and I'm just left with my, whoops, go back. I'm just left with my my correct graph. The final thing to do is to work out where it crosses the oh, what is happening here? Apologies. That goes like that, and you go like that. So where does it cross the x-axis? That's what I need to work out next. Now the x-axis, I need to work out these points here. So that happens when the y-coordinate is equal to 0. So if I just get myself some space up here, and I will set now on the new function the y-coordinate equal to 0. So I'm going to have 0 equals k minus the modulus of 2x minus 3k. And whenever I solve a modulus equation, you solve the original equation, and then you solve when you change the modulus sign. So I'm also going to solve k plus 2x minus 3k. Okay, let's solve this one first. We're going to get 0 equals k minus 2k, and then we're also going to get minus 3k, so that's plus 3k. And this tells me that 2x is equal to 4k, so x is equal to 2k. And this must be this one here, 2k. I can actually tell by symmetry, because we go from 2k to 1.5k, this is going to be just 1k. And that would be the solution to this second equation, which I'll just solve quickly as well, because that would be k, and then that will be plus 2x, and that'll be minus 3k. So we would end up with 2k equals 2x, so x would equal k. And that is the final sketch with all the points labelled. Next we have this inequality, And that part of the inequality is the bit we've already labelled with a light blue pen. And the next part is a straight line that has a gradient of x, so it's going to be shallower than this line which has a gradient of 2x, and it goes through a y-intercept of minus k. So it's going to look something like this. So it's going to cross the blue line twice. We need to work out both of those intersection points. So the first one will be when I solve this equation with the modulus sign not changed. And solving this equation would give me 4k minus 2x equals x minus k, and then it would give me 5k on this side, 3x on this side, so it would give me x equals 5k over 3. So that's one point created. So I've solved it with the modulus being negative, and now I'm going to solve it with the modulus being positive. So that would be plus 2x minus 3k, and that would be equal to x minus k, and then that would be k plus 2x minus 3k is equal to x minus k, and then we would give 1x on this side, we'd have minus 2k added to the other side, and I'm going to get k. So great, I've got the two intersection points where the purple line crosses the light blue line. And in fact, we want where the light blue line is on top, is greater than the purple line. So we want this part here. So we want it bounded in between those two intersection points. Now the way we write that in set notation, which is what they've asked for in set notation, is we say that first off, x must be greater than the smallest value, which was k, and it must also be smaller than the larger value. So it's bounded in between the two of them. And that is the solution then to part B. Now part C is essentially a graph transformation question. Again, it asks us for the minimum point, which might be a bit confusing because if you look at the graph already, there's only a maximum point. But that's because when we multiply the function by a negative, the graph is going to reflect in the x-axis, and thus that maximum will go down to the bottom and become a minimum. So let's look at what each bit of this graph transformation does step by step and see what happens to the minimum point at each step. So at the moment, if I just redraw the graph, we have the point, roughly speaking, here, and that is at it was 1.5k, comma k. Okay, I'm going to start first with the f of a half x. That's a graph transformation which stretches the graph in the x-axis by 2. So the new graph would look like this, and the new minimum point will be the x will be doubled, so it'll be 3k, and the y will stay the same. So we'll be at 3k k after that transformation. Okay, and then what would happen next? Let's say we multiply it by minus 5. Well, when I times it by the minus, it's going to flip on its head. So it's going to look like that. And then timesing it by the 5 is going to stretch it down. I mean, it will stretch it further than that, but that's just showing what it will do. So the y will change into a negative and multiply by 5. So the x will stay the same, but the y will be times by minus 5. So it'll be minus 5k. And then finally, we're here at 3k minus 5k. And the last thing is plus 3. So we're plussing 3 to the whole graph, which is going to translate it up by 3. So it's just going to go up like that by 3. So the y will change, it will be increased by 3, so it will be 5k plus 3. And that is going to be our final answer. That's what the graph will look like, or the minimum point will look like on the new graph. Integration by substitution. First off, start with the substitution you're going to use, and then we want to differentiate that in order to find an expression for dx. Now, when there's a root x, differentiating can become quite tricky. So I always recommend making root x the subject and then squaring both sides like this to get an expression for x, and then differentiating that. So if I write that as x equals u minus 1 squared, and if I differentiate that with respect to u, I get dx by du. And if I differentiate this, I would bring the 2 down to the front. I would drop the power down to a 1, and then I would differentiate the inside of the bracket, which would give me 1. So multiplied by 1 just gives me what I have there. So dx is equal to 2u minus 1 du. And that's really straightforward. That can go straight in for the dx part. The next thing I need to do is change my limits. So I'll draw a little table of values here, and I'll write x and I'll write u. And the x values are 16 and 0. Now u is equal to 1 plus the square root of x. So 1 plus the square root of 16 is 5, and 1 plus the square root of 0 is 1. And then I think we are good to go. We can substitute in to our new integral. So the new limits are 5 and 1. We have x on top, which we've got this rearrangement for x here, which is u minus 1 squared. We have 1 plus root x on the bottom, which is just u, because that was the original substitution. And dx, we know, can be replaced with 2 lots of u minus 1 du. So I can now rewrite this as the integral between 5 and 1 of, well, u to the minus 1 times u to the minus 1 squared is u to the minus 1 cubed. There's a 2 there, and that's all over u, and that's du. Now, whenever you have a constant, so in this case, this is multiplied by 2, I can take that outside of the integral. Only constants though. It just makes it a bit easier. And the only way I can integrate this is by expanding that top bracket. And I'm going to do that. Well, when I expand that top bracket, you can trust me on this one, you get u cubed minus 3u squared plus 3u minus 1. And that is all divided by u, so I have to divide each term by u. So that will give me the integral between 5 and 1 of u squared, and then minus 3u plus 3 minus 1 over u du. Okay, and now we're going to integrate this. So once it's integrated, I put it in a square bracket. I up the power by 1 to get u cubed and divide by the new power. Don't forget the 2 that needs to go outside as well. And then I up the power by 1 to get squared, and then divide through by 2. This is going to give me 3u, and the integral of minus 1 over u is minus ln of u. And that's between 5 and 1. Okay, and now we substitute in to our brackets, into our u. So I'm going to get 2 lots of, and I'm going to get 125 over 3. I'm going to get 25 times 3, which is 75 over 2. I'm going to get 3 times 5, which is 15. And I'm going to get minus ln of 5. and then I'm going to take away 1, so I'm going to get 1/3, and I'm going to get minus 3/2, and I'm going to get plus 3, and I'm going to get minus ln of 1, which is 0, so I can leave that out. Okay, right, go into the calculator. 125 over 3, and then minus 75 over 2 plus 15. I'm going to leave that ln 5 alone, and that's going to equal this. Then I'm going to take away, in brackets, 1/3 minus 3/2 plus 3. Great, so I'm going to get 2 lots of 52 over 3, and we've also got this minus ln 5, which I missed out. So multiplying that through by 2 is going to give me 104 over 3, and then minus 2 ln 5. And I believe that is the form they want it in. Yes, sounds good to me. Okay, parametric differentiation, you need to differentiate the y with respect to theta and the x with respect to theta. Now, differentiating the y, I would set y equal to cosec cubed, and then I would set y equal to u cubed, and u equal to cosec theta. I'll then differentiate with respect to u and get 3u squared, and I would differentiate with respect to theta and get minus cosec cot. And then, using the chain rule, I would multiply those together to get dy by d theta. So I get 3u squared is cosec squared, and I'd multiply that by minus cosec theta cot theta. So overall, over here, I've got my dy by dx, and the top part, the numerator, will be minus 3 cosec cubed theta cot theta, and then the denominator will be the x derivative, which will be 2 cos 2 theta. Okay, now we've been asked to work out what the gradient is when y equals 8. Well, the y coordinate is equal to cosec theta cubed, and I want that to equal 8. So cosec is the same as 1 over sine, so 1 over sine cubed theta equals 8. So rearranging gives me sine cubed theta is equal to 1/8, which means that sine theta is equal to 1/2. And of course we know that if sine is 1/2, then the angle is 30 degrees, or pi over 6. So now I need to sub that into my derivative. And I'm going to be a little bit cheeky here because I know that cosec cubed, when theta is pi over 6, gives me 8. So I'm just going to replace that with an 8. I'm then going to do cot of theta. Well, I know that tan of pi over 6 is equal to 1 over root 3. So therefore cot of pi over 6 is equal to root 3. So I'll times that by root 3. And then all over 2 times by, and cosine of pi over 6 times 2 is cosine of pi over 3, which is 1/2. So I'm going to end up with minus 24 root 3. Okay, for this question, I need a bit of extra space because there's so much information. Now, these questions are very similar, and the first thing to start off with is working out the volume of the shape. So the volume of the, or the volume, sorry, should I say, of the liquid inside the shape is going to be 3 times 8 multiplied by h. So the volume inside the shape is going to be 24h. And this tells us that dV by dH is equal to 24. So that's going to be useful. Next off, let's look at all these bullet points that we're going to need to use. So the depth of the water in the tank is h. So I've just used that bit of information there to work out the volume. The next part says the water is flowing into the tank at a constant rate of 0.48, and it says water is leaving the tank at a constant rate of 1.8 h per minute. So the rate that water is coming in or out of the tank is going to be the change of volume with respect to time, because that's what rate is. It's how something is changing with respect to time, and we're looking at the water coming in, so that's the volume of the water. Okay, so what is that then? Well, it's positive, something's coming into the tank, 0.48, and there's something leaving the tank, so that's going to be negative 0.1 h. Okay, great. And now, what are we actually looking for? We're looking for an expression for dH by dt. Well, by the chain rule, dH by dt is equal to, well, let's put a dt on the bottom, and I have dv by dt, so that will help. And then I want those v's to cancel, so maybe I need to do dv on the bottom, and let's flip this one over and put dh on the top, so that's going to work nicely. So essentially this is then this 0.48 minus 0.1 h, and it is multiplied by 1 over 24. So all over 24. Okay, so let's do some rearranging. Let's times both sides of this equation by 24, which is going to give me 0.48 minus 0.1 h. And then I think that's very similar to what we have, but it looks to me like it needs to be multiplied through by 10 and 5, so by 50. So I think if I just times everything through by 50, I'm going to get what they asked for. 50, I should double check that, I don't want to make a mistake here. 0.48 times by 50 is going to be 24, yeah, okay, that's nice. Okay, so 24. And then minus 5h. That's perfect. Okay, and then it gives us an initial condition. So when the tap was opened, whoops, that's meant to be highlighting. When the tap was open, the depth of water was 2 meters. And it says show according to the model that h is equal to that. Okay, so what I'm going to do is I'm just going to get rid of this bit of working here to give myself a bit more space. And I'm going to move this bit up here. Okay, let me just write it out again. So we are going to have 1200 dt by dh by dt is equal to 24 minus 5h. And we also have an initial condition that when t equals 0, we have that the depth of the water is equal to 2. Okay, so what we're going to do next is we're going to solve this differential equation, and we're going to do that by multiplying both sides in the first instance by what are we going to multiply it by? Let's go with dt, so that we have 1200 dh is equal to 24 minus 5h dt. So that gets dt on the right hand side, and then let's move this over here to get 25 minus 5h dh, and that's equal to dt. So now all of the h's are on the left side and all the t's are on the right hand side, so we've split the variables up, separation of variables, and we can now integrate both sides. Okay, so let's do that then. Let's integrate both sides. So when I'm integrating this fraction here, I look at this and what I'd really like is if the derivative of this was equal to the numerator, because then we can use our Lun rule for integration. Now the derivative of that blue bit is minus 5. So if I wanted that top bit to be minus 5, well, what I would need to do is I would need to take out a factor of minus 240. So that's what I'm going to do. I'm going to take out a factor of minus 240, which means I can divide the top line by minus 240, and that's going to give us minus 5. Perfect, so I can write that as minus 5 there. Okay, because minus 5 times minus 240 is the 1200 which we had on the top. And that's really helpful because now we can just integrate this using the Lun rule. And the Lun rule states that if the denominator's derivative is the numerator, then the integral will just be Lun of the numerator. The denominator. And then I need to integrate dt, which just integrates to t plus a constant, let's call that c. And now what we do is we use our initial condition to substitute into that solution to find the value for c. So when t equals 0, the right hand side just becomes c, and h will equal 2, so I'll have minus 240 ln, and if it was just 2, then I'd have 24 minus 10, which is 14, so ln 14. Okay, so therefore my new equation, my solution is going to be minus 240 ln of 24 minus 5h, and I'm going to have t, and I'm going to have minus 240 ln of 14. Okay, now how am I going to solve this? Because I need this in terms of h. Well, what I'm going to do in the first instance is I'm going to add that 240 ln 14 to this side. So I'm going to get 240 ln 14 minus 240 ln 24 minus 5h is equal to t. I'm then going to take out a factor of 240, and that's going to leave me with ln 14 minus ln 24 minus 5h. And what we know when we do, and when we take one ln from another, I can write it as those two ln's divided by one another. So I'm going to get 24 minus 5h like that. And that's multiplied by 240. And that's equal to t. Okay. I'm now going to divide both sides by 240. So that's going to give me ln 14 over 24 minus 5h is equal to t over 240. Let's just make that a bit bigger there. And then I can take e of both sides to get 14 24 minus 5h is equal to e of t over 240. And then I'm going to swap this fraction over. So I'm going to take the reciprocal of that fraction to get the h on top. And in doing that, it's going to flip over this e to the t. So that'll go on the bottom, like that. But that's the same as it being a negative power. So I could just call that e to the minus t over 240. And I know that's going to be quite helpful because if I look up here, they want it as e to the negative power. So that's really good. Okay, and now it's just a case of rearranging for h. So multiply both sides by 14. E to the, let's call that 1 over minus t over 240. Doing a little bit of a rearrangement here. Forgive me for skipping a few steps, but I don't want this video to be too long. Like that. And then finally, so h is going to equal, dividing through by 5, 24 over 5 minus 14 over 5 e to the minus t over 240. And I think that is done. Just quickly checking the mark scheme, praying that that's right. I think that's good. Okay, right, next part, C. Given that the tap remains open, determine according to the model whether the tank will ever become full, giving a reason for your answer. Well, for the tank to become full, h must equal 5. So let's solve that and see if that happens. So does h equal 5 is essentially the question that they're asking us. Well, I mean, I can tell already it's never going to become 5 because, well, what is this term? That term is 4.8. So h actually equals 4.8 minus something. And what do we know about e functions? Well, they're never going to be negative. So what we can say is, as t tends to infinity, this 14 over 5 e to the minus t over 240 will tend to 0. And this means that h will tend to 4.8. So therefore, the tank will never become full. Right, converting into a single trig function. My top tip for this is look at what function you're converting into and then make sure that that particular function, in this case cos, that coefficient is the a value. So in this case a equals 2. And then look at how many signs we have. There's only one sign there, so that's the b value. So we say b is equal to 1 here. And then we just use this formula, which is great. It is the square root of a squared plus b squared. So in this case, that's the square root of 2 squared plus 1 squared, which is root 5. And then the alpha value is equal to tan to the minus 1 of b over a. So in this case, that's tan to the minus 1 of a half, which is 0.464. Great. That's 3 easy marks. Next part, we want to use this, what we've worked out, to rewrite this function. So the first thing I notice is that where we had theta before, we've now got 0.5t. And also you can tell that the coefficients are now 4 and 2, so they've been doubled. So it's been times by 2. So let's use that and let's rewrite that function there. So h is equal to 3 plus, and then like I said, it's been times by 2. The r value was root 5. It was a cosine function, and theta is now 0.5t, and then we add on alpha, which is 0.464. And the question asks us, what is the maximum height that you can achieve? Well, what do we know about the cosine function? We know that it has a maximum of 1, because the cosine graph goes like this, and it goes no higher than 1. So therefore I can say the max h we can achieve is 3 plus 2 root 5, and then times by the cosine of 1, times by cosine, which I know is the maximum of 1. So that just gives me a value of 3 plus 2 root 5. And then the next part of the question, I believe, says find the value of t for when that maximum height does occur or first occurs. Well, once again, I know that the maximum height occurs when the cosine function equals 1. So let's solve this equation. Take cosine of to the minus 1 of both sides, and cosine, the inverse cosine of 1 is 0, as you can tell from the graph, and also 360 or 2 pi. So I'm going to write here 0, I'm going to also write 2 pi. And then I'm going to subtract 0.464, which is going to give me minus 0.464. I'm going to have to do 2 pi minus 0.464, which gives me 5.819. And then I'm going to double them. Well, this one already I can tell is not going to be usable because we can't have a negative time. So it's the second one which we're going to use. And I'm going to double that. And I'm going to get t is equal to 11.6. And that's in seconds, I believe. Okay, next question. It says a single revolution of the wheel, and it wants to know how long it will be below the water level. So the water level here is when h equals 0. So I want to know when it crosses that threshold. So what I'm going to do is I'm going to set h equal to 0. And h is 3 plus 2 root 5 cosine of 0.5t plus 0.464, and I want that to equal 0. Okay, let's rearrange for the cosine function. And that's going to give me minus 3, and then divide that by 2 root 5. So let's take cosine to the minus 1 of that. Cosine to the minus 1 of minus 3 over 2 root 5. And we get 2.31. So I'm going to get 0.5t plus 0.464 is equal to 2.31. Now, whenever you find a trig function, you want to find the second value, and the second value for cosine is 2 pi minus the first value. So I'm going to do 2 pi minus answer, and I'm going to get my second value, which is 3.977. Let's go over that. 3.977. Okay, so those are the two values, and the cosine function is going to go down and hit 0, and then it's going to go under the water and then come back up again at 0. So let's find what these values are. So first off, let's subtract 0.464 to both of them. 0.464. And I get 3.51, and then I'm going to times it by 2 because it's 0.5t, and I'm going to get 7.0 3, so 7.03. So that's that one there, and that's equal to t. And then let's do the same for 2.31. 2.31, I'm going to take away 0.464, and then I'm going to times it by 2 in order to get t on its own, and I'm going to get 3.692. So the time we're looking for is the time underwater, so it's this time there, and it's the gap between these two times. So if I just do 7.03, subtract the last answer, I get the gap of 3.33. So 3.34 seconds. And the last question asked me to explain the, in reality the water level may not be constant. Okay, so the so if the water level is not constant, then where is my formula? Sorry, yes, my formula here. If it's not constant, well, all of this varies with time, but the free sort of stays constant. But if the water level is not constant, then this would also need to vary. So I would say that the free value needs to vary.